Hello, everybody. My name is Michael Merrington. I'm the General Manager of Index. We would like to introduce you to Index webinar number 10, EXO and EXK, known as either oil immersion, liquid filled, or as they're known now, liquid immersion. I will be turning off the webcam so that you can concentrate on the presentation. Thank you very much for attending. Okay, let's go into the basics. How a transformer works. Well, a transformer has two or more coils linked together by a common core conducting the magnetic flux. The flux from one coil, the primary, passes through the other coil, the secondary, inducing a voltage in the secondary winding. Now, one side could be your input and the other one is your output, but you can use a transformer as a step up or step down in voltage. So by varying the current in the coil creates a varying field, okay? The current is induced. Now, by improved design, they've placed an iron core between the coils. This allows alignment of the magnetic domains, which intensifies the magnetic field. A transformer is to increase can increase a voltage by a factor of 2 if you have double the amount of windings. So you usually have an iron core. So we're just going into the basics. So when we're talking about oil-filled transformers, this is a typical non-EX oil-filled transformer. Everything inside is lubricated, cooled by the oil or liquid, and there's a radiator and a fan. Think of the engine in your vehicle where the oil is going through an oil radiator and is being cooled. There's also a reservoir, an oil pan, a reservoir of oil, which then you would also have a breather and also a level gauge. So these HV and LV isolators, your connection points, are outside. So this would not be acceptable for hazardous areas. But it's to give you an idea. There's also oil drainage points and gas sample lines. So what does a liquid immersion type? What is the purpose of the oil? Well, it absorbs the heat produced by the internal components of the core of the transformer. And then that allows it to radiate through the body equally to allow that the heat does not become too much to potentially ignite the potential hazardous atmosphere outside. So it is absorbing all the heat. Now, why are transformers dangerous? We've seen multiple events every year of transformers blowing up. So if we're going to use them in hazardous areas, we really have to make sure that their construction is of high quality and will be protected from producing too much heat and will be higher quality to ensure that it does not fault and cause something like this to happen. So within New York, this transformer blowing up had big impact on the city. So when we talk about EXO transformers, to the standard IEC 60079-7, we're talking about protection via liquid immersion to EXOB or OC. So EPLs, yeah. So GA, GB, GC. We're specifically talking about GB and GC, so zone 1 and 2. For OB, it can only go up to 11 kV RMS, and OC can only go up to 15 kV. So we are only talking about low or medium voltage transformers or other EXO devices such as switchgear. Now, it will never be high voltage or extra high voltage as per the standard. Now, let's ask you guys a question. This one might seem a little bit random, but anybody who's been attending weekly, you should know the answer. Is an IP68 device rated for IP66? 70% voted. Give another 30 seconds. I'd love to get up to 90%. Don't be shy. All voting is anonymous. It will not show who voted for what. I will never know as well who voted for what. 85%. Okay. So for the people who voted 16% yes, that is incorrect. Please watch webinar 4 and 5. IP67 and 68 does not give you protection for the 5 or 6. Yeah, doesn't give it to you for IPX5 or 6. And even below that, I question it as well. IP69 does not give you any of the other ones from 5, 6, 7, or 8. Okay, now let's ask a question. Where do you think you would find, which standard would you look for the EXO inspection sheet? Standard would you go to find the EXO inspection sheet? Okay. So 36% of you, you're going down the right path for -17, but it is not there. -6 is for EXQ, quartz, sand, so that is not correct. -14, you would think for the initial detailed inspection, you would find it there, but it is not. We're specifically asking the inspection sheet. The actual answer is -7. You'll find out later why. So when going through EXO or EXK, the most important thing to consider in this order is the certificate, the manufacturer's IOMs, installation, maintenance, and operation manuals, then the standard. Client specification should not invalidate any of the above. If the certificate goes against the standard, you do as per the certificate. If the IOMs and certificate go against the standard, you do as the certificate and the IOMs. You do not inspect things only to the standard. The standard is only a minimum. Anybody who has ever taught you that you inspect to only the standard, or that the standard is what you should be shooting for, that is incorrect. The order of precedence is you follow the certificate, then the manufacturer's IOMs, then the standard, and make sure to not invalidate it via the company's, the client, the end user specification. So let's ask an IP question again. Oh, I didn't put it there. Let's go to the next slide. Okay, liquid immersion. Well, liquid immersion in EXO is the type of protection in which the electrical equipment or parts of the equipment, electrical equipment, are immersed in a protective liquid in a way where an explosive gas atmosphere, which may be above or outside the enclosure, cannot be ignited. So it's excluding the gas from being near the terminations, the bus bars within the transformer. Now, the protective liquid, it's a liquid which prevents, once again, it from making contact with potential ignition sources. So potential ignition sources, heat, arcs, sparks. Oh, sorry, not -7. I made a mistake on the last one. Sorry, guys. I was referring the wrong standard. So the answer for, I made a mistake here. That should be -6. Apologies. Now, protective liquids. What do we need to consider? Well, there's a lot to consider. The determination of the voltage breakdown at a power frequency, how it's tested to that, its relative permeability, its dielectric dissipation factor, its resistivity, what type of liquid you can use, mineral oils, silicones, and other things. There's a lot of standards that need to be followed, but specifically within the standard 5.1 protective liquid specification, the protective liquid shall be a mineral oil conforming to IEC 60296, or a liquid silicone to 60836, or a synthetic organic ester liquid to 61099. But a future natural ester liquid to 62770 is under consideration. But have a look. Synthetic esters are manufactured by combining alcohols and carboxylic acids. So these liquids may be flammable. That is okay. So if we ask you the question, a little bit random again, but what is the minimum IP rating for an EXO device? Give another 10 seconds, we'll get about 62% voted. Okay. So the correct answer for EXO is minimum IP 66, meaning the answer cannot be 67 or 68. Okay? That is not a correct answer, because 67 and 68 do not give you 66. IP 54, remember, is only a minimum in the standard. If a manufacturer buys an IP 66 device and gives you an IP 66 gland, why are you invalidating their installation if you don't maintain IP 66? So, construction requirements for EXO. What do we have? Well, we have an equipment being protected, surrounded by oil. It will have a dipstick or a level indication. Yeah, and the hazardous area will be outside. So via exclusion, it excludes the hazardous atmosphere from getting close to the piece of equipment that could cause a potential source of ignition. So what construction requirements do we need to look at? Well, level of protection, switching devices, creepage and clearance, liquid containment enclosures, immersion depth, protective liquid level indication, temperature limitations, wiring methods, constructional elements of enclosures, and operating rods and shafts. So when we go to levels of protection, we have EXOB or OC. So for zone 1 or zone 2 or EPL, GB or GC. Well, for OB, our switching devices have to have a working voltage of 1000 volts RMS VAC. While in EXOC, they can be up to 6.6 kilovolts. Now, creepage and clearance distances must meet the relevant industrial requirement for distances in air. So if we ask a question in a moment. So liquid containment enclosures. Connection bushings provided for the termination shall be considered as part of the enclosure and shall be subjected to this clause, meaning it must have chemical resistance. So any of the bushings inside have to be chemically resistant because they are either immersed in oil or above, and they will have oil on them. Now, sealed enclosures, these need to be permanently sealed and cannot be repaired. They need to be labeled with that. Unsealed enclosures will have gas or vapors that can escape through a breather. So if you have a breather at the top here, we'll have a breather with a drying agent. The manufacturer shall specify the maintenance requirements. Outlets or breather devices must have a minimum of IP66. So the outlets or breathers shall have an IP66 rating. Enclosures intended to be opened need to be identified with a warning. This enclosure is factory sealed. Consult manufacturer's instructions for repair. What they mean is when even they open it up to do maintenance, they kind of mean repair at the same time. Now, determination of the maximum and minimum criteria for the protective liquid, you need to know its maximum level, its minimum level, and the maximum working angle of the equipment. So if a transformer or whatever device is full of oil, at which angle can it be mounted on the ground? It may be on an angle. There may be vibrations that make the oil level move. So it needs to be able to withstand that. So are creepage and clearance distances that are required in oil, are they less than air, more than air, or the same as air? So do the creepage and clearance distances need to be the same as air, less than air, or more than air? So if you had 10 millimeters in air, in oil, do you have to have the same measurement, or does it have to be less or more? Okay. So the correct answer is same as air. 23% of you got it. We go back a slide. Creepage and clearance distances must meet the relevant industrial requirements for distances in air. Okay. So the creepage and clearance distances within the oil-filled device does not change. It shall be as if it was in air. Okay. Immersion depth. There's a big table to follow. If you're working at up to 15 kV with no switching device, you have to have 15 millimeters of depth. If you're working at 50 volts or below, you're only looking at 3 millimeters. Which standard spells out the creepage and clearance distances? The relevant industrial standard. So you would need to look at whatever IEC standard it would be for a type of transformer or switchgear. Depending on what type of device it is, it will be a different industrial standard. So it will not be an IEC 60079 standard. It'll be a different set series of standard. Now, protective liquid level indication. It needs to be marked with the minimum and maximum levels of protective fluid allowed. Think of your car, your oil, if you do an oil change, what's the maximum amount liters of oil you're allowed and the minimum amount. Now, the levels at which the EX equipment shall be filled under filling temperature conditions specified by the manufacturer. Can you fill this at 50 degrees Celsius or when it's minus 40? Read the IOMs. When a dipstick is used, the marking, warning, replace after use shall be there. Now, remote indication, the switching element needs to be below the indicator, and it must be EX. It must be rated for hazardous areas. Now, safety devices for EXOB, the switching element must be below the indicator, it must be EX, but also it has to have automatic disconnection of power below the minimum level. And it shall have a fault tolerance of 0 and have a safety, a SIL level of 1, okay? Safety integrity level. Now, temperature limitations. The maximum surface temperature of an EXO device shall be as per the certificate, but it shall not exceed 200 degrees Celsius. So basically, EXO, you will never find a device greater than T3. It will be T3, T4, T5, or T6. What standard is applicable for SIL ratings? I believe that's IEC 60511 and IEC 60508. I may be wrong there. 61511. Somebody will tell me in the comments and I'll pass it on. So the maximum surface temperature shall not exceed 200 Celsius. The flash point of the protective liquid must be a minimum 25 K greater than the exposed protective liquid or the temperature of the internal components immersed in the liquid. Yes, so the IEC standard for SIL ratings, IEC 61508, and also consider 61511. Now, construction requirements. This is on the screen, so let's ask you a question. Can a cable be terminated in an EXO enclosure? Put 52, 56%. Hopefully people can keep voting. Okay, so the way that I read this is not many people have worked with EXO, and you need to consider that 44% of you, I'll show you why you're wrong. When you look at an oil-filled transformer, see this sidewall. If there was a hole here, the oil is going to spill out. If you had a plug there and you wanted to put in a cable, the oil will come out. If you put a cable gland there and a cable, the oil will go up the cable or down the cable. Field wiring connections shall not be made within the liquid immersion. Bushing shall be used for connections through the wall of the equipment. Direct entry is not permitted. You never make your terminations within the EXO device. The only connections done in there are done by the manufacturer. The only time you'll get access to them is when you do a shutdown turnaround and take the transformer offline for maintenance, for an oil change, like an oil change for your vehicle. So when we look at a typical EXO transformer, it's not just EXO. It includes other protection techniques. Now, when we look at this, here's your terminal enclosure. Here's your oil compartment reservoir. Then you have EXE terminal boxes, and then you have an EXD. And you also have intrinsically safe cabling going other locations on this piece of equipment. So what does that all mean? Well, this enclosure up here is where the MV or LV line side and load side terminations will be made. The cables will be entered either from the side or from the top, but certainly not through this cover. Not through this cover. This indicator here is a level indicator, so it would be intrinsically safe. It could be IA, IB, or IC. These terminal boxes are, well, for terminals. There would be EXEB or EC, perhaps in the past, NA. Now the EXD, that's where you would find heat producing equipment, perhaps switches, contactors, something like that. And there's even a Y seal, a barrier between the EXD and E boxes. Now the other intrinsically safe cables would probably be going to temperature devices, other level indicators, pressure indicators, and such, safety devices. Now on the bottom, these are your oil drainage points. So if we look at this device, I believe this is an oil-filled rectifier. Well, what do we have? Well, we have EXD terminal boxes on the left and the right, and then you have an EXD control panel with heat producing equipment here. But there's also conduit seals. Also because this enclosure is full of oil or protective liquid, whatever they filled it with. So here's another example of the one that we showed you before from a view from the other side. So this one here, that could potentially be a temperature sensor or a pressure sensor on the main enclosure. Yeah, that would be an EXE enclosure where we do the terminations. So here it is when it's open. It then has another box inside. There could also be heaters up there, space heaters, EXDE space heaters. And then we have this one up here. That could be a sonic, could be an instrument for level indication, an ultrasonic, perhaps. Then when we look at this one, what's interesting about it is its entire terminal enclosure is at the top. Now, when I look at this device, I automatically know it's a zone 2 because see how this is just a visual indication of temperature and level. Zone 1, OB, it has to be a SIL rated instrument. Okay? So let's ask a question. We already asked this one. Let's see how everybody responds now. Are creepage and clearance distances in oil, do they have to be less than air, more than air, or same as air? Another 10 people have joined in the last little bit, so maybe somebody will give it a different answer. Now, everybody, the answer is same as air. The oil does not reduce any requirements or does not give you extra protection when it comes to creepage and clearance distance requirements. Okay? The oil or liquid is for cooling, dissipation of heat produced. Now, here's an example of a rectification transformer. Now, they didn't follow the manufacturer's requirements because while it has been bunded to capture any leakage of oil, they don't have any drainage. So as the bunding fills up with water, you can run into problems with the transformer. Now, the enclosures for EXO devices are either fully welded or if they're unsealed, they'll have gaskets. So their IP rating, it's not really tested, but the vents are minimum IP66, meaning IP66 all the time. And as we said, terminations are not made in the EXO enclosure. They're mounted other EX protection techniques on the transformer. So usually when you come across a transformer like this, your certificate is going to say EXDEIO, DB, EB, IA, OB, perhaps. So you need to know all the different protection techniques and to know those letters to be able to understand that this is one entire unit. You cannot remove one of these or receive it without these. It has to be as per the certificate. Same with this one. Now, what key documents must you have for installing, maintaining, operating, and inspecting an EXO device? So there's 3 documents we spoke about before that are an absolute requirement. %64 voted. Give another 10 seconds. Now, the most correct answers are the IOMs, installation, operation, and maintenance manuals from the manufacturer, the certificates, and the standard. You must have all three to be able to install, maintain, inspect, and operate these transformers safely within a hazardous or potentially hazardous area. Now, it's also very good to know that EXO will not just be EXO device. You will have D and E or potentially just EXD on it, but you'll also probably have intrinsically safe. As for having your complex, that has nothing to do with EXO. The order of precedence, always follow the certificate, the IOMs, then the standard with the manufacturer specifications as well, which shall not invalidate those three others. And if any of them contradict each other, you follow the first one, certificates, then the manuals, then the standard. Now, let's talk about EXH, or as it used to be known as, specifically for liquid filled, EXK. This has now changed within the last few years. A device will no longer be labeled as EXK, it'll be EXH. So if you had an EXD motor and you had a gearbox, this would be EXDH or DBH or DCH. So what do we have here? Gearboxes are the most common filled one. Liquid filled or liquid immersion device for EXK. Another one is compressors. So how does it work? Well, think of just like a motor. You have camshafts or gears. Well, in a motor, all these are coated in oil. So the same thing for these gearboxes. They can be EXK, liquid immersion type, okay? So what are important considerations? Well, to IEC ISO 80079-37, you need to consider minimum and maximum criteria of the liquid, the minimum and maximum levels, the minimum and maximum pressure or flow as well, because it will be moving around like the engine of a motor. The oil will move around. Now, the protective liquid, it will be protection via exclusion by providing a continuous coating or film on the potential ignition source. So on all the metals that are moving that could produce sparks or hot surfaces. And it must not produce a hazardous atmosphere. Now, no voids or bubbles or mists shall be caused by moving parts or in service, and or a chemical reaction between the liquid and the materials of the device. So the camshaft, its metal shall not react with the liquid. But flammable liquids can be used, okay? Now, the equipment construction is important because what is its working angle? Is it going to be on a 45-degree angle? Is it going to be perfectly level with the ground? It needs to ensure the effectiveness of the liquid. It needs to be filtrated. It has to have a high IP rating of IP66 for when it's a high levels of dust or vapors. IP23 when it's vented or sealed enclosure. And the liquid must be as per the manufacturer's IOMs and the standard and the certificate. It shall avoid accidental loosening via good design, cementing, lock washers. You need to monitor the level of the liquid. You need to monitor for loss of liquid, or to ensure there is no loss of liquid. And opening of equipment, if there's any parts that can be opened, the maximum temperature of any surface of the protective liquid exposed to atmosphere shall not exceed the max temperature of the overall piece of equipment. So if the equipment is rated T3, 200 degrees, if you open one piece of it, which is meant for inspection or filling it with more oil or liquid, that one area shall not be greater than the temperature of 200 degrees, like the overall device is rated for. So, EXK, what testing needs to happen? Well, as per the standard, there's increased pressure tests of at least 1.5 times the working pressure, with a minimum of 50 pascals overpressure. Okay, there are specific tests for non-electrical, meaning mechanical devices. Now, what about documentation? Well, IOMs, documents shall be made in accordance with this standard, -36 80079, and it shall include exactly what we were talking about: minimum and maximum liquid levels, pressure and flow, minimum and maximums, details of maximum working pressure, maximum working angle, details of the liquid used, its minimum viscosity, specific mounting instructions, instructions related to maintenance, requirement for duty life, replacement, replenishment, disposal of the liquid. Where applicable, instructions regarding the periodic internal cleaning to remove deposits that could self-heat, and instructions about the commissioning, initial filling, and putting into service. There's a lot involved. Now, when we go to EXO, the requirements are, yes, you follow -14 for installation and -17 for maintenance, but you go back to -6 and you refer to Annex A, selection and erection of the equipment. Field wiring shall be made with a type of protection suitable for the application, meaning you do not enter the cable into EXO. The liquid immersion is not an accepted type for field wiring. Also, another thing, your cables have to be oil resistant. Now, for repair, there are other considerations that need to be taken into account. Basically, follow the manufacturer's IOMs, installation, operation, and maintenance manuals. So as we said, the inspection sheet for EXO is found in -6 standard. The inspection requirements of 17 are supplemented by those in this table. So while you will have an inspection sheet as per -17 for the other EX protection techniques on the transformer, because as we showed, it's not just by itself EXO, there will be D and other devices protection techniques. These questions are specifically for O, asking minimum maximum criteria of protective liquid. How much liquid is in it? Is it too much? Is it too little? If it's intended for opening, you follow that. Dipsticks, remote indication devices, switching devices, gaskets. So this is specific for EXO. If you do not have this inspection sheet, or perhaps you've been doing inspections without these considerations, perhaps you've been doing your EXO inspections incorrectly, perhaps unsafe. Now, for EXO liquid immersion, what about marking? Well, there's a lot of marking requirements as well. It has to be marked with what protective liquid is used, which pressure relief device is used and its setting. It shall indicate if it's either a permanently sealed or whether it can be permanently sealed or if it's factory sealed, meaning that it can be open, but it has to be open and closed as per the IOMs. It has to be repaired, as they say. Now, the levels of which EX protection are followed, so EXOB or OC, and it shall be on the EX data plate. Mentions of dipsticks, mention of short circuit capacities, and warning labels. Now, instructions, well, they talk about the frequency of replacement of the liquid, information for use of disconnectors and tap selectors. So if you have a multi-tap transformer, maintenance requirements for the drying agent for the breather device for unsealed enclosures, and instructions for cleaning, filtering, and replacement of the protective liquid following a given number of normal switching operations and following interruption of fault currents. So interruption, meaning how many times has the transformer been turned on and off? The more you turn it on and off, the more faults, the more wear and tear you put on it. Also during fault currents, so short circuits, overloads, too much lightning strikes, any fault, anything causing a fault current. An inspection obviously needs to happen. Make sure that nothing has broken down, no insulation. Now, what are important factors involving liquid immersion? Involving the liquid. What are important considerations? The last one should say sealed or unsealed enclosures, not sealer. So remember, when we say oil filled or oil immersion, that was the old word. Now they say liquid immersion. So it can be a silicone, it can be a mineral oil, it can be an ester. I think this one has people unsure. 60% voted, we'll close it now. So the correct answer is all of those. You need to know the minimum and maximum levels that are allowed. You need to know what liquid type, yeah, because you can't just replace it with whatever you want. You need to follow the maintenance requirements, and you need to know if it's a sealed or unsealed enclosure. A sealed enclosure you cannot open. An unsealed enclosure you cannot open unless you follow the IOMs. Follow the manufacturer's instructions and the certificate and the standard. One more question. This is more of opinion. Is EXO and ESK similar? Just give your opinion. So they're both liquid immersion. Okay. So half of you think that they are not similar. I would say they are more similar. It's liquid immersion. It's being used to reduce the chance of an explosion due to overheating. The oil, the liquid, the silicon, the ester, is absorbing the heat and dissipating it equally all around to the point where it gets to the outside body and will not ignite the potential explosive atmosphere outside. You have to do oil changes. You have to double check the level of the oil or liquid. You have to ensure you're using the right viscosity of the oil or liquid. I'd say that they're very similar. There are different electrical considerations, obviously, between the electrical and mechanical, but down to the basis of it is the oil or liquid the correct type? Is it maintained? Is it filled up too high? Is it filled up too low? Is there any impurities? I would say they're very similar. Okay. So that's the end, and we're going to open it up to questions. We already have one. I'm going to go back to one of the ones just so that if anybody asks any questions, maybe it's a little easier. So somebody said, why can't IP68 be used on IP66 rated device? So if you have an IP68 gland and it's only IP68, that means it's never been tested for IP66. It has not been verified or validated to be rated for IP66. Please watch webinar 4 and 5 to learn all about IP ratings, how things are tested, and what is rated for what. Now, any other questions? How can I access all the webinars? We'll send through a link with our YouTube, and you will be able to access all the previous webinars. Ralph, I see your hand up. You can ask a question. Anyone who has registered for this webinar, your emails, we automatically include them in our list and we send the invite to everybody on Thursday or Fridays. Double check your spam folder. It may sometimes go there. Thanks, very formative, but is this technology worldwide yet? Yes, EXO is used worldwide. Since the Americans have adopted AEX, American EX, so UL 60079, they do allow oil-filled transformers, liquid-filled transformers, as an EX protection technique. They have roughly 20 LNG projects going on in Texas and Louisiana, and they are using these types of transformers. Now, where can these transformers be located? Well, you can put them inside the battery limits, if anybody's ever worked on an LNG project. So ISBL, inside battery limits. And so it can be right next to the substation. Okay? And the reason why? Because, well, now it's EXO. What's the difference between IEC and NEC standards for classification of hazardous locations? Depends. IEC, you can follow zoning, or you can apply EPLs, which is a risk assessment. NEC, if you're going by classes and divs, is a much more restrictive method with less protection techniques available. So it's more expensive. So it's less flexible and more expensive. For NEC 505, for classes and zones, it is different than IEC. You cannot use IECX equipment in America unless it has had specific electrical testing to their electrical standards, NFPA NEC 70. EXD glands are always rated IP66? No. They are tested at an EXTL, a testing laboratory, and they will always have a sealing mean, so an O-ring, a gasket, or an IP washer for their testing. The minimum that they have to be is IP54. Do you have a social media group where all EX professionals can communicate? We have our YouTube channel, our LinkedIn page, and we also do have a few websites in which we communicate on. So I'll show everybody at the end here. So if you go to ind-ex.ae, or you email us at info@index.ae, we can answer all your questions. Once again, we'll also share the webinars with all of you. How do we deal with non-electrical equipment inspection and EX register? So if you're asking about just non-electrical, well, you can derive the inspections from electrical and consider the non-electrical considerations found here, and basically make your own inspection sheets regarding non-electrical. It will be coming in the future standards. They're suggested inspection sheets of how to do non-electrical. How to do the inspections? Use your best people. Use the people that understand EXO to begin with, and the importance of certificate, IOMs, then standard. Remember, just because you have a certification, an EX personnel certification, such as the one that we mentioned before, that does not make somebody competent. Competency can be proved many ways. Now, as for the EX register, you can use it in the same register as your electrical equipment. Can you provide another sharing of non-electrical EX equipment from documentation, review to inspection according to ISO? So within 80079-36 and 37, all that exists is this information. There are no inspection sheets yet defined for non-electrical. If you would like that, please contact us. Okay? We do have experience with non-electrical. Now, how often should we do a zoning review? That's open to interpretation. Some countries say that there should be a review every 5 years, or that an ignition review, so ignition hazard analysis, should be done every 5 years. Can a classification be done yearly, a classification review? Yes, it can. What's in the best interest of the end user? Well, it depends on their facility. What are their environmental conditions? Is it onshore? Is it offshore? Is there H2S? Is there salt air? Is it cold? Is it hot? Is there big temperature swings? What type of process is it? Is it a chlorine plant? Is it oil and gas? Is it hydrogen? If it was hydrogen, I'd be doing an ignition hazard analysis yearly. We are located worldwide. Our main office is located in Budapest, Hungary. We're also located in UAE, but we also do have operations Canada, America, Australia, Turkey. Wherever you are, we can assist. Yes, South Africa, we do have people there as well. Can you run a webinar on area classification? Yes, we can, but it will be basic. But we do offer customized training. We also offer ICX COPC, personnel competency training. So any of the 11 units from unit 000 to unit 10. We also do ATEX training and certification, as well as HASLOC, so North American. Our contact in South Africa is the contact through us. Please contact us and we can arrange. If there are no other questions, I'll give it 10 seconds. HASLOC training is North American. They don't call it hazardous areas, they call it hazardous locations. So NEC, North American Electrical Code, and CEC, Canadian Electrical Code. So HASLOC, the original words were for hazardous locations, which is North America. America and Canada, and sometimes Mexico. Okay, I want to thank everybody for attending. We really do appreciate your time, and we hope you attend next week. Have a wonderful morning, afternoon, and good evening.